discussions related to the material properties of UHPFRC, application of this material for rehabilitation, conclusions and recommendations based on our own experience. I decided not to present some other topics because this is just something related to our work in the university, so probably it will be more interesting. Maybe in future we can have the opportunity to see some other topics. We have three main pillars when we are discussing the sustainable development. So we have the economy, the environment, and the society. And here in the middle, in the intersection of these three pillars, we have the sustainable development. So normally, the sustainable design and the sustainable development related not only to the execution, to the realization of new projects, and very often the highlighted topic in this area is how to extend the service life of existing structures. So that was the reason to concentrate the presentation on the strengthening of existing structures, and also of our team to go further in the strengthening of some bridges and orthotropic decks of bridges, existing bridges, for their future life and their future use in the practice. Why this problem is so waste coming from demolition, construction, and remodeling takes more than 35% of all non-industrial waste. It means that we have a lot of problem with the waste because the construction and the operation of building and facilities have in general the main contribution to the environmental impact. So say that the decision to construct a new structure or to rehabilitate and strengthen the existing one is decisive for the final design solution. So here we found that the problem of the strengthening of existing very significant. So the idea to find the life of these structures is decisive for the sustainable development. In parallel with the adaptive reuse, the second very important part in this topic is the use of new construction materials and new technologies. So for us, it is necessary to say that the contemporary structural solutions for rehabilitation and strengthening, and in general the philosophy of the sustainable design, are related to the application of new high-tech and smart construction materials. So finally, the retrofitting based on these new materials can extend the service life several times, and in this way to reduce the environmental impact. Of course, during the design, it is very important to find the balance between the retrofitting impact and the mitigation of the operational impact, which is very important for the preservation of the environment. So based on this, I will present you some general information concerning the UHPFRC and, of course, what was the experiment conducted in our laboratory. UHPFRC stands for Ultra High Performance Fiber Reinforced Cement based composite material, which is produced from cement first, some powders, additions, hard fine particles, water admixtures, and of course, very important, a high amount of relatively short steel fibers. So the main objective of this composite material is to make the existing structures durable and strong, and to extend their life. So finally, I will repeat again, and I bold it in red, that the structural UHPFRC is really a very smart, light, and durable material. So unfortunately, I have no time to introduce one second experiment in our laboratory. It was apart from the PhD thesis of one colleague from the university. She had a very interesting results for the durability of UHPFRC subjected to some aggressive environment. And of course, this problem is very important and related to the function of our infrastructure sites. In general, in the practice, the UHPFRC is used for both strengthening and for new design. But my presentation is concentrated on the topic of strengthening and on the adaptation and the opportunity to extend the life of existing infrastructure sites. Normally, the UHPFRC could be applied in two variants. The traditional case where we have UHPFRC layer between 25 to 40 millimeters and normally is used as a protection. But in parallel with this case, we have the opportunity to put some rebars and to increase the layer up to 40 to 80 millimeters. So in this case, we can combine not only the protective function of UHPFRC layer, but the structural resistance. So here, this illustration is giving one idea about the two types of UHPFRC. Here on the left, we have the protective function. It is one good opportunity, especially for infrastructure sites where we have some effects from the atmosphere. But in the same time, if you want to upgrade the bearing capacity, we can increase this additional layer to put some rebars inside and to improve not only the protection, but in the same time to increase the structural resistance of our structure. So here you can see the difference between the two materials. On the bottom side, we have the typical cross-section through the conventional concrete, and on the top you can see the layer executed by UHPFRC. Using this material for existing structures, we can have a very significant improvement, and just extending the service life cycle, we can, in the same time, to prevent the production of more construction waste, but in the same time to update and to upgrade the behavior based on the modern use and the modern standards. So it is one very good opportunity. This is one illustration. It is just for visualization, the application of such layer of reinforced UHPFRC on the bottom side of one bridge, just to see, how does look this material, a little bit specific, different from the conventional concrete. Especially in Bulgaria, the first research on UHPFRC started in 2010. It was a research project with the participation of research team from our University of Architecture, Civil Engineering and Geodesy, in cooperation with scientists from the Bulgarian Academy of Science and the University of Artois, France. This is the first time in Bulgaria when we started with the research on UHPFRC. It was a funding from the National Fund Scientific Research at the Ministry of Education, and the specific scientific project, the super high strength concrete, an alternative for building high-rise buildings and transport facilities in the Republic of Bulgaria. So up to this date, 2018, the main topic in this research was how to make the mix. That is the big problem, because finally we have different options based on the experience of some other countries, but the idea of the new project in 2018 was related to the application of UHPFRC, mainly in the practice, not only to focus the research on the properties and the mix and the material characteristics. So the objective of this new research started in 2018 was to investigate the possibilities of the production. It was the first one by local concrete plants out of the laboratories, and of course to gain some national experience in strengthening of existing steel and concrete structures by the application of the ultra high performance fiber reinforced concrete. Finally, I will present mainly the strengthening of existing steel structures, because our test specimens were based on some bridges already executed on one of the highways in Bulgaria. Especially the concrete structures, the experiment was a little bit limited in concrete structures. We had some specimens of beams, but these beams were made in general just to see what is the behavior based on our mix. So for the moment, maybe related to the topic of this webinar, it will be more interesting to say something about the test concerning the specimens from existing bridges. Normally, the first step was to produce the material, as I told you already, that the idea was to see what are the possibilities here on in our country, not to use some imported mixes. Usually the UH-PFRC mixes contain around 650 to 900 kilograms per meter cube cement, microsilica, some fine particles, quartz, basalt. But very important is that we have a maximum grain size not exceeding 1 millimeter. Something very specific is that the ratio, the water cement ratio is very low, between 0.30, 0.70, and it was really a big challenge, not only to produce the mix, but how to apply on the test specimens. So normally, just to improve the execution of the concrete layer from UH-PFRC, it is a very good opportunity to use some super plasticizer to obtain more workable mix and to have the opportunity to compact this mix. Usually this basic matrix of UH-PFRC is strengthened by steel fibers. Normally the size, the length is between 13 and 15 millimeters. So in the different countries you can find different, how to say, different advices how to proceed. I'm trying to give you more general information concerning this part of the mix. And normally the ratio is related to the minimum 3% in volume, which means around 240 kilograms per meter cube. So the idea is to have high tensile strength and significant tensile strain hardening behavior, which is very important for the application of these materials. So normally the evolution of mechanical properties of UH-PFRC as a function of time depends, of course, on the composition and what is the mix, the thermal treatment and the curing. So it's really necessary to take special cares just to realize the good contact between the existing concrete, the new layer, and in the same time not to have some cracks provoked by the shrinkage, because the process of shrinkage is very, very intensive here because of the very high level of cement content. As a general information, I put here the diagram between the strain and the tensile stresses and displacement and force for the two variants. But the most important is that we have in the beginning a very long branch of elastic behavior. Then we have the hardening phase and then the toughening phase. So the mechanical response of this material is very influenced and depends on the orientation of the fibers. So it is very important that the anisotropic fiber orientation is usually mitigated by high fiber content. And of course, as I mentioned in the beginning, if you want to improve the bearing capacity, you have to use some reinforcing bars using some wire fabrics or meshes prefabricated and conducted on the site just for the top layer. The rebars, they are very good not only for the resistance, but they improve the deformation capacity and the strain hardening. So it is a very interesting characteristic. And for us, mainly when we are talking about the strengthening for increasing the capacity and enhancing the tensile behavior, it is very important how we will proceed with the steel fibers and the additional reinforcing mesh. Usually the behavior of UHPFRC under compression is characterized by a rather linear stress-strain relationship. It was clear from the diagrams, and normally the compressive strength typically is between 130 and 180 megapascals. Some authors are discussing this limit. For some authors, this limit is 150, and this is around 200 megapascals. But finally, I will repeat one more time. It is very important what is the mix. The modulus of elasticity is between 45 and 50 gigapascals. The shrinkage and the creep of UHPFRC are similar to other cement-based materials. Very important here is to mention that the shrinkage is very intensive and develops rapidly. About 60 to 90% of the total shrinkage is completed after not more than 50 days. The most important here is to mention that the drying shrinkage is not so relevant for the shrinkage, the total shrinkage of the UHPFRC, because we have a very low water cement ratio. The biggest part is provided by the endogenous shrinkage due to the intensive processes inside of the matrix. We have, it's not a part of our test, the fire resistance, and because we had no time and financing to provide such experiments, but based on the practice of some other countries, we can say that adding, for example, some polypropylene fibers, we can avoid the spalling of UHPFRC when we have very high temperature. So it is a topic which is necessary to be studied in the future. Concerning the abrasion resistance and the chemical attacks, I told you we had the defense of such PhD thesis on Thursday, where it was proven by different mixes and different chemical agents that this material can have a very good behavior under aggressive environment and aggressive conditions. So it is very good to be used for bridges or other infrastructure projects. Concerning the application of UHPFRC for rehabilitation and strengthening, I can say that this basic conceptual idea started in 1999. It was very important that since this date, we have many intensive and active development of this topic. Unfortunately, I told you that we have not so big experience with the application of this concrete. For the moment, maybe the most intensive experiments are conducted the last 10 years, more or less. So it was proven by different authors and by some researchers here in our country, that the strengthening of the structure, using UHPFRC layer is very good for the cases where we have de-icing salts, very typical for bridges exposed to some very severe conditions, marine environment, very aggressive liquids, and in the same time, as I mentioned, for the abrasion resistance, we can use this material for some high mechanical loadings. For example, where we have very big concentrated forces, fatigue, impact abrasion. So you can see that it is one good opportunity to improve the behavior of our structures based on these characteristics. Some information about the experimental tests and the strengthening of the orthotropic steel deck that were produced in our university. You can see here the test specimen and the test setup in the laboratory. You can see here the production of the mix of UHPFRC, the steel fibers, and here Dr. Komara had the opportunity to see these specimens in our laboratory. We here have the already prepared a surface. I will say something about the preparation of the surface. So we have these two specimens ready for the loading. It is very important to say something about the surface, because one of the most important things during the strengthening, not only with UHPFRC, but in general, is how to make the connection between the existing material and the new material used for the strengthening. Of course, on this topic, again, in the literature, you can find many different recommendations. Some of them are just not to use any additional devices. Some of them are proving that it is very good to use some dowels. Especially in our experiment, we decided to make the following preparation of the surface. We use a primer from Sika, some epoxy, and some quartz sand. So you can see here the preparation of the orthotropic steel deck and just the application of the quartz sand. Here are the amount, the quantity used for the preparation of the surface. So we decided not to use any dowels. Of course, it is a matter of future researches to upgrade, of course, this connection, but the most important was to have good contact, stiff contact between the two layers. Finally, you can see the drawing about the longitudinal section, the size, and the cross section, the size of our test specimens. The most important here is that the orthotropic steel deck specimens are full-scale segments between two cross girders. The geometry is chosen to correspond to one of the existing steel road bridges over the Hemus Highway in Bulgaria. And as you can see, this bridge is built in 1986, so far away from today. And this is the reason just to provide these specimens based on the real bridge. The production of the UHPFRC was done by one of the biggest company producing concrete in Bulgaria. Hydrobeton is the name. So they have their own original recipe based on cement 52.5, microsilica fume, metakaolin, quartz powder, super plasticizers, and steel fibers and water. So finally, they produced their own mix. That was our idea, not to use only the laboratory mixes, but to see what we can find on a real site. They were very enthusiastic, and the concrete, the UHPFRC, was a donation for the research project, so it was a very good opportunity for us to make the strengthening. Here you can see the drawing of our test specimens before to start the experiment. So in parallel with the execution of the test specimens, we made a model, finite element model. So we found that there is a very good agreement between the results, because as you can see, for example, for the vertical displacements, the difference was between 9 and 15%. About the strains measured in the stiffeners of the specimens, the difference again is not so big. So we have a very good agreement. From the calculated stresses, but it was clear that we have a serious problem in this bridge, because the characteristic value of the applied load leads to relatively very high stresses in the longitudinal stiffeners, and very close to the yielding limit of the steel. So that was the big problem, because as I mentioned in the beginning, the big problem in existing bridges is the very intensive road traffic. So in addition of this finite element method with the applied UHPFRC has been also developed. And finally, when we made the new model, a finite element model of the strengthened element, the results were very good. And again, we had a very good information. So we found that we have around 63% reduction in vertical displacements. So without the strengthening, the displacements were 2.72 millimeters, and they decreased to 1 millimeter. And around, very important about the capacity of the stiffeners, was that we have a very intensive, very big reduction in the normal stresses of the longitudinal stiffeners, around 60%, which is very important. I put just in the presentation, this presentation is available. I have sent it to Dr. Komara, so I will not give any additional details. Here is the table, loading steps and calculation from the finite element model, and then the comparison of the results from the tests with a force 150 kilonewton applied load. So we have the results from the test specimen and the finite element model. So finally, we found that the layer used for strengthening of our orthotropic steel deck is a very good opportunity to upgrade the behavior of this type of infrastructure projects and this type of bridges, because we have a lot of bridges and projects realized by this system. I put here one very brief example, but because we have no already in Bulgaria the application in a real structure, we are trying to find some funding for this. but I put here the example of the so-called Calland Bridge in Netherlands, where you can see that the application of a layer similar to our layer, you can improve the behavior of this bridge. It is very interesting because in general, the fatigue cracks are a big problem for the orthotropic steel bridges, and especially the cracks in the steel deck. So the resurfacing of this bridge in Netherlands by only 45 millimeters show a stress reduction with a factor 4 to 5 in the fatigue critical structural details. So it is very optimistic as a result, and I hope that we will find the opportunity to apply this material in some real sites and to prove the real effective application of this composite material. So finally, I want to summarize by the end the area of application. We can find in protection, waterproofing, but in the same time, for me, most interesting and most important is the rehabilitation and the strengthening combined with the protection for some severe impacts. It should be, of course, some bridges, some parapets, crash barrier walls, piers of bridges, and so on. We can use strengthening of building slabs. I told you that I had some experiments based on the reinforced concrete beams, but in general, you can use for strengthening of the capacity of reinforced concrete slabs for industrial buildings and some industrial floors. And of course, to use for some containers and tanks, just to avoid the chemical attack and the aggressive waste water attack. It is necessary here to say something concerning the application of the steel fibers. So it is necessary to have at least 3% from the volume to obtain a good tensile strain hardening. So finally, the very high price of the steel fibers, because they are really very expensive, and we imported them. We had no available here on our market, so they were imported from Germany, especially our fibers. But it is one problem for me which is not so significant, because finally we are using these expensive fibers, but we have a very good performance and improve mechanical properties of the structure. So finally, for us, we can say that sometimes raised cost issue related to relatively high fiber contents of UHPFRC is insignificant, as the pure material cost for UHPFRC often is less than 20 to 30% of the total intervention or construction cost. How we can upgrade in the future the behavior of this composite, something related to the price and the sustainability. It is, for example, to replace some clinker by limestone filler, to replace the fibers by high modulus polyester fibers, and of course, the implementation of this material is one very good opportunity to sustain the principle of the sustainable construction. So one layer can fulfill several functions: increase resistance in bending and shear, increase stiffness and reduce fatigue stresses, act as a waterproofing layer. And of course, don't forget about the surface preparation. So here it is possible to have more intensive researches just to prove which one is suitable for the different cases. But in the practice, I told you we have different recommendations, but usually it is good to prepare by hydrojetting or sandblasting, and of course wetting the surface before the application of the layer. So I hope that it was not so long. Thank you for your kind attention, but I decided that
we work into a different fiber. You are working on a steel fiber, but I'm working on a polyvinyl or a synthetic fiber. So I have a question, but I will save it for the last. Let's see several questions coming from the participants. So again, everyone, if you want to ask directly to Prof. Marina, I will give you the time and the allocation time to ask right away. But if you have a difficulty to deliver the information in English, you may also write it in Bahasa. I will try also to deliver the question to Prof. Marina. And here coming one of the question from Nafisa. As we know that UHPFRC is made from a fiber material, a steel fiber material, how the efficiency of the fiber that will relate to the tensile strength of the UHPFRC?
Excuse me, can you repeat the last part of the question?
Okay.
I couldn't hear very well. Okay. The beginning I hear, but the last part,
okay.
how the fibers?
The efficiency of the fiber that will relate to the tensile strength.
It is a matter of mix. First of all, as I mentioned in my presentation, it is the choice of the length and the diameter of the fibers, then the orientation. So these are the three main parameters which is necessary to control during the mix. So we put around 3% from the volume, the fibers, but of course, it is not the unique mix. So in the different countries and the different concrete plants, you can make different mixes. The problem is how to reach the mechanical properties of the material. I don't know if it is the answer, but I understood in such way the question. If you want, I can clarify. But finally, the amount of fibers is very important for the tensile behavior. The problem is that they are very expensive, so we have some minimum recommended in general, but of course you can make different mixes. It is a matter of of testing the parameters. So usually you have to produce previously some tubes or cylinders, yes, and to have the information.
Okay. Yeah, possibly the questions coming because like we normally identify the portion of the fiber at first before try to implement the material to the side of the construction. So the question coming probably how do you have a suggestions about the presentation of the fibers? Like you mentioned that it's not the unique composition, but this is coming from the advice from the others references, right, Prof?
Yeah. We used just some recommended amount, percentage of fibers, and it is not very interesting, but we have some limits in the money in the funding. So we bought the minimum which was necessary for the production of the mix. So we had no opportunity to make experiments with the content of the fibers. So for the moment, I cannot say which one is the optimum. I know that in general, we have this minimum. And of course, in each situation, you can make experiments to see. Some of the researchers, they are making specific orientation of the fibers as well, just to improve the behavior. Yeah. So here I cannot say some recommendation, just use this amount of fibers, because I told you we had not so much money to buy more fibers and to make the experiment. But it is a good advice to have it in mind for future. Yeah.
Yes. That's the same matter here. Actually, it's like if we conclude and try to identify the new or a novel material, we have to make the material first available in our place, and that's a big deal actually. And there are also another questions coming from Pak Hoiri. Is there any special requirement to prepare surface of the old concrete to maintain the bonding between the new and the old material? And is it suitable for all of type of old cement concrete? That's the first one. And the second one, what is special behavior of UHPFRC so it has waterproof capability?
About the preparation of the surface, we made, especially in our experiment, we decided, because we found in the references many different advices. And as I told you, some of the applications are recommended to be done without any preparation, just to clean the surface, to wet the surface, and to apply directly. It is on one side. On the other side, we found some recommendations, for example, to use dowels. For example, some steel rebars as dowels distributed on the surface. We decided to do something between the two recommendations. Finally, we prepared the surface with a specific primer from Sika, just on the top of the steel deck. And then we have a very thin layer of a quartz sand, just to improve the interface between the new layer and the existing. So during these experiments, we had no the bonding of the existing, the bonding between the new layer and the existing structure. But maybe in parallel with the steel fibers, you can make, for example, for some specific cases, different variants of the interface contact.
What about the second one, about the waterproof capability?
The big deal here is that we have a thixotropic mix, very dense, and normally we have a very low level of penetration of the water and of the aggressive agents. As I told you, we had one defense on Thursday. Our colleague presents such experiments for the intensive water and chemical attack for different specimens, and she has proven that really because of the specific structure, we have very fine powders, very fine material, and very low water cement ratio. So it is really like a waterproofing layer, and very often it is used not only for improving the capacity, but just to stop the penetration of the water. Mm-hmm. So it's a very good opportunity for infrastructure projects to use this material for waterproofing directly as a layer for directly use, and in the same time without any additional layer for waterproofing. So to combine both, that is one good opportunity for the application of this material finally.
I see. I see. And another question also coming from Bapak Nur Ahmad Hussein. He's the one that really study more about the durability. As far as I know, he conduct the study more into a geopolymer concrete in terms of the durability aspect. And he asked that how does the steel fiber affect the durability of the concrete, especially comparing to the normal concrete?
More the steel fibers, it's my opinion, of course. I think that the steel fibers more are related to the tensile strength of the concrete. Of course, they are improving the density of the material, but I don't think that the contribution of the steel fibers are related so much to the durability than the amount of the cement and the amount of the other powders and admixtures. So this is my opinion concerning this question. I don't know what is the opinion of this colleague, but really the steel fibers are mainly dedicated for the improvement of the tensile behavior and the strengthening of the structure. Sorry.
Okay. Okay, another question is coming. Wow, you have a lot of questions. It seems like your presentation is quite interesting to be followed. Is there any difference or a typical type of the failure for UHPFRC compared to the normal concrete?
Especially, I can make some comments concerning the strengthening. Because the test was conducted in this direction. The big problem is for me, and it is typical for all the cases of strengthening, it is the debonding. So this is one of the biggest problems for all layers used for strengthening. It means, I think that you have to take special care for the contact, because it is possible one of the failures to be as a result of the debonding, and if it is applied on a reinforced concrete, you can have the spalling. For example, if the element is not steel but reinforced concrete, you can have the spalling of the concrete and the concrete cover. So these are the opportunities for failure of strengthened with UHPFRC elements.
I see. Okay, you still have another questions. And what are the disadvantages of the UHPFRC? And then what are the limitations of the performance based on this concrete?
What are the advantages?
Yeah, disadvantages.
About the advantages, I think that I have already repeated this, and I will repeat now that the advantages for the structure and the application of this material is that we have very good opportunity to increase the capacity. And something very important concerning the big problem with the foundations here we can use a very thin layers, as you can see, between, for example, 40-45 millimeters until 100 maximum. It is the maximum 80-100 millimeters. And for me, the big advantage of this material is not only the durability and the resistance, but it is the very low increase of the self-weight. Because normally when we are making some strengthening of structures, we have the problem with the foundations, and of course with the pillars of the bridge or the foundation of the building. So for us, using materials with very small thickness or very low self-weight is good, not to go and to make further, how to say, further construction works concerning the strengthening of the foundation, because it is too expensive, and sometimes if you have to improve the foundations, it will be a big problem and it will be quite expensive. So for me, the combination between the mechanical characteristics and the very low self-weight are the big advantages of this material. Disadvantages is the price, of course.
I see.
Usually, you know, when you have a ring with a diamond, we can buy only a very small diamond. So, but as I mentioned by the last slide, of course, the big price, the high price of this material. But in the same time, the challenges and the problem is the production of the material, because of the low water cement ratio, we have a very intensive process of hardening, and the biggest problem is how to make the transport from the concrete plant to the site, because if you want to strengthen a bridge, of course you have no plant just behind or near to the bridge, so you have to make the transportation. And based on my information, many cases, for example, in France, in Switzerland, where they are very active with the application of this material for strengthening, they are trying to make a small local plant near to the site, just to skip this process of transport and to realize the concreting very fast. Because if you have a long period of time of transportation, it will be not good for the material, and after that for the application. So this is the big deal. And the big problem is the execution. It's necessary very often. You have to make some temporary, like a hole with some just to cover the space, the workspace, just to minimize this very intensive process of shrinkage. So these are very big problems. That was the reason to start our project, but we have for the moment no money to continue. I have many ideas, but the money is not enough. Really, because in the laboratory everything can happen, but the problem is that we want to go out of the laboratory and to provide this material to the construction site and to use it not only in specimens, because the specimens is okay.
Yeah, that's the correct way here. So like, yeah, we have the same interest. And as you know, I have one of the colleagues that's really working on it, the steel fiber. And we have one or two industries providing the steel fiber. So possibly I can reconnect one of the colleagues. So I hope that we can also have opportunity such collaboration in terms of the steel fiber, because like we have several variety of the steel fiber, And the industry really need to join in terms of the development, the study, and the investigation how to use that type of the materials. So I will try to connect one of my colleagues with you.
Yeah.
And then absolutely. We can also have another research. So just let's see near in the futures. I hope we can have a good deal about this type of the project.
Of course. I'm very keen for this topic, and really, I think that because we have a lot of examples in the real practice, realized more than 20 years this material is on the market. As I told you, the most important is how to produce this material in real conditions of the construction site, because I told you, especially in Switzerland, I had the information, and I have I read some publications. They are trying to extend the concrete plant near to the site, just to produce the material, and very fast to make the concreting, not to lose the time. This is a big problem, and it's necessary to be solved, because it will be not attractive for our investors to have problems with the application. So we have to recommend something good and practical as a recommendation.
That's the thing here. I think it is also the same way with our department here. It's like we try to approach the student, including the industry here, that really have problems in terms of the construction project. So we can also help to solve and give them a good deal in terms of the consideration aspect. So thanks for your presentation. Such an interesting presentation. It's like it
was a great pleasure for me. Sorry to interrupt you, but I'm really happy for our contact. It was our meeting was very strange. I was not expecting, just when Tzveti found me and told me, do you want to meet Indra Komara? I say yes. And I'm happy that I said yes, really. Thank you so much, Indra, and thank you to all the organizers to give me this opportunity to contact you. And I really hope, on the behalf of my colleague and on the behalf of the university, that we will have the opportunity to have future collaboration with you. Thank you so much.
We will. We can talk about it later more. And then we also have another like activity, research activity, and so on. So we can keep in touch in that time.
Of course, and I'm available.
Absolutely. It is possible like to have a joint class within our subject, but we can discuss it more in details later. Again, we, on behalf on our department here, the head of the department and also the dean of the faculty members, I would like to thanks for participating, for joining our event. It's an honor for us for having you here. Like there are a lot of questions coming, and also the student really interested to see your presentation, and it also relates to our research. So we can talk more about it in the next occasion.
Thank you so much. All the best for all of you. I wish you health and very successful year by the end, and the next and the next, all the years. Okay.
The same is coming from you. So in the next question, I'll give the time to the master of the ceremonies. Time is yours.
Yes. You can send me by mail. So success and good luck. I'm leaving. Thank you so much.
Thank you for participating again.
Thank you. Bye-bye. See you all you again. Bye.
See you. Bye.
Okay, well, thank you to Mr. Indra as moderator, and also Professor Marina is the keynote speaker for being willing to fill out today's webinar. Okay, previously there will be a certificate submission which will be represented by Mr. Hoiri. Or the
Tapi
comment on that game.
sepertinya sudah leave, Mbak.
Oh, okay.
Marina.
Okay, we can
Yeah.
skip. Okay, before we end today's webinar, let's take a photo. Okay, the audience may be able to on cam. And for the comment on that, they can help with documentation. Okay, here we have 5 slides. Okay, maybe we go with. Okay, we're gonna start with the first slide. 1, 2, 3. Second slide. 1, 2, 3. Third slide. 1, 2, 3. The fourth slide. 1, 2, 3. Last slide. 1, 2, 3. Okay, Alhamdulillah, we have reached the end of the event. Thank you very much to the speaker, moderator, and also participant who listened to the event from beginning to end. Hopefully, a lot of knowledge can be applied in everyday life. I want to reminder for participants who have not filled the attendance can fill in the attendance first, but the link is in the Zoom chat. Okay, see you in the next webinar series. On behalf of the Committee on Dandi, I apologize for the wrong words and action. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Hoiri, terima kasih semuanya Bu Familia, Bu Ninda.
Terima kasih Pak Ikom.
Iya, sama-sama Pak.
Terima kasih. Mudah-mudahan nyambung seterusnya. Pak izin live
Iya,
ya.
amin. Iya.
Salam untuk semua mahasiswa S1, S2 dan semuanya di sini.
Oke, Bapak.
Ya, ingatkan kembali kepada para peserta webinar, mungkin yang belum isi link bisa segera isi link absensi kehadiran dan juga feedback yang telah dikirim panitia melalui kolom chat.